Hey, hello everybody. I'm Michael Drexelis, Director of Graduate Affairs at Baylor University, Department of Chemistry and Biochemistry. I'm also a research faculty member in the area of biochemistry. And really, what I want to do today is give you an overview of Waco, of Baylor, and more deeply into our graduate program and requirements. So um, I'm going to go through a presentation today, um, and I'll be able to discuss some of the intricacies of our program and some of the overviews of the bigger program. So I really want to thank you for being with us today. I know this is virtual format is not really ideal for really anybody at this point, um, but we wanted to make sure that you had a lot of opportunities, both live and recorded, to get a good idea of what our graduate program is like at Baylor, and hope to convince you to come join us next fall. So what I want to do is share my screen, and we'll be able to go through some slides on the area and what it's like to be at Baylor. And so this first slide overview just gives an overview of the facilities we have at Baylor. So right here and central to this slide is the Baylor Research Science Building, or the Baylor Science Building. Also down here on the right-hand side is the Baylor Science Building from the other side. And then some other um, buildings across campus, including the administration building called Pat Neff and the Arts and Science Administration here building over here. And then down here at the bottom, two of our bears housed on campus are saying hello, or doing the sick 'em bears to you as a way to welcome you to Baylor. So just a little bit about Waco, Texas. We're right in the middle of central Texas, so we call it the heart of Texas. It's a medium-sized city. Population is the 25th largest in Texas, with around about 200,000 people in the area. And I think one of the major benefits of coming to graduate school at Baylor is the inexpensive cost of living. And so it's pretty easy to afford an apartment here in Waco. You can easily live on the graduate stipend that we provide for you as an incentive to come to Baylor and teach and do research. And so that's really, I think, a big selling point. It's also very rapidly growing, renovating. Hotels, restaurants in the downtown area seem to have really expanded and taken off even since I've been here, going on now 6 years for me since I moved to Baylor. The weather is in the middle part of Texas, so it can definitely be hot in the summertime. I prefer the fall, the winter, the spring, really mild temperatures and areas there, including now, right? So it's really been great to get you to Baylor during this time. It's a beautiful time to be in Central Texas in the middle part of the winter season. So Waco is pretty much right in the middle of Dallas and Austin. It's easy 2 hour drive to, or less than 2 hour drive to either Dallas or Austin. College Station as well, and about a 3 hour drive to Houston or potentially Galveston in the coast. And so we are centrally located, low cost of living, but really easy ability to get to a lot of different places in Texas. We have several museums and attractions, points of interest in Waco that I think you guys are going to enjoy. So, a couple things about Waco is we are the home, or the founding of Dr. Pepper was in Waco. And so we have the Dr. Pepper Museum here that kind of highlights that accomplishment. Many other sort of Hall of Fame museums, etc. in Waco. The one I like is the Waco Mammoth Site, which is now a national monument site, which shows the mammoths and baby mammoths actually fossilized, of course, in this facility. Arboretums, we have skate parks, distilleries, wineries, all kinds of things in the area to highlight. Events that students really like are the farmers market, which occurs on Saturday morning. Many concerts at night, of course. They have not happened this year, but they have in the past and will continue in the future, the Brazos Night concerts. Other fairs and radios, of course, and many other activities to kind of keep you busy in Waco. The central picture here is the Brazos River. Baylor is right on the Brazos River. And in fact, we have a bridge that goes across the Brazos River. And so it's a major artery, waterway in Texas. Um, so that is the Brazos River, and provides a lot of opportunities for the area. Of course, most recently, we're famous. Waco is famous for having Chip and Joanna as residents of the area, and also um, on their Fixer Upper television show, which many of you may be aware of. But more than that, they really contributed a lot to the growth and the development of the Waco downtown area, including the silos where they have their shops and food trucks and gardens and etc. They also have a restaurant here called Magnolia Table, really close to Baylor University, and a new coffee place opened up by the silos, actually. And so Chip and Joanna have really done a lot for Waco in bringing the spotlight to Waco and just allowing for a lot of growth and development of many restaurants and other resources and bars and restaurants, I guess, and other activities that just weren't here 6 years ago. And so we've really just had a rapid growth area. So outside of Waco, well, really still in Waco, but really on the shores of the Brazos River is Cameron Park. It's the largest, one of the largest municipal parks in Texas for hiking and biking. Beautiful views of the Brazos River. It's home to Cameron Park Zoo, which is it's a really nice zoo. Actually, it's got lots of animals there and place to go and see. And it's got world-class mountain biking trails actually in Cameron Park. And so really if you're into that, just be careful. You got lots of mountain biking opportunities there. No alligators or crocodiles in the Brazos River, of course. You have to go all the way to Houston or Galveston or the coast for that possibility to see those guys. Lots of water sports and arenas in Waco, including Lake Waco itself, a really big reservoir that feeds the city, but lots of boating, hiking, fishing, trails, picnicking, swimming, all that stuff can happen in Lake Waco. Brazos River and the Bosque River as a tributary to the Brazos River. We have the Hawaiian Falls Water Park here, lots of water slides in the summertime. And we have BSR Cable Park, which has got wakeboarding, surfing, and a massive slide that you can propel yourself off of in the summertime as well. We have 3 institutes of higher education in Waco. One is a couple community college and technical colleges called McLennan Community College and Texas State Technical College, along with, of course, Baylor University. So Baylor is the oldest continuously operating university in the state of Texas. It was founded in 1845 and then moved to Waco actually in 1886. We have somewhere in the range of 17,000 students on campus and more than 3,000 graduate students now. So I would call this a medium-sized university. Some of it may be large to some of you, but compared to some of the larger universities, I think it's more medium-sized. Again, we're located right on the Brazos River. We do associate with a law school, which is in Waco itself, associated with the medical school and some connections in Houston. The dental school and the nursing school, of course, are in Dallas. Lots of sports accomplishments and achievements associated with Baylor University and stuff that you guys can take advantage of as graduate students to go watch and see. Not just football and basketball. It's surprising to see that tennis and equestrian and acrobatics and tumbling and soccer, all those sports and more are routinely in the top 25 and many in the top 10. And so it's really quite an accomplishment. Some scenes around campus, just highlighting some of the buildings. Again, Baylor Science Building is here. Over here, we can see the basketball arena and stadium where you can go to, and then some other buildings on campus. So it really is kind of a shame that we're not able to invite you to come for a visit and show you how beautiful the campus is. But we're going to have to do our best virtually to sort of imagine that many opportunities and experiences you can do at Baylor. Including, football, we are sort of famous for Roger Griffin III, who won the Heisman Trophy back in 2013. But the women's NCAA basketball team won 2 years ago, right? So they were the champions in 2 years ago. And in fact, they won 8 out of 9 Big 12 titles over those years. And our coach Mulkey, right here, is the fastest to 600 wins in women's basketball. Down here, we can see the bears. So we have a live Baylor bear habitat on campus. You can see it here. It houses two of our brown bears, Joy and Lady. And you can go visit them on campus. It's right next to the Student Union building. And what was interesting to me, I just looked this up in 2021. So currently, right now, we have 6 sports in the top 10, including tennis, equestrian, acrobatics, and tumbling. Probably missing a few here. And then we have 5 more in the top 25. Of course, basketball, both men's and women's basketball in the top 10, 5 more in the top 25. And so it's really quite an accomplishment for a medium-sized university to have that many sports outlets. McLean Stadium is our football stadium. It opened in 2014. It can hold 45,000 people. It is located on the Brazos River, just across the river from campus. And there's a nice bridge that'll take you across to the stadium on game day if you so choose to go to a game. Here you can see the bridge walking across the Brazos River to the stadium. And then many years we've had College Game Day come when Baylor football's been in the top 10 or so. They've come for an exciting event. And so it's a pretty stadium. And in fact, our graduate recruiting weekend dinners and some activities are a lot of times held in McLean Stadium. They have been for several years. And so it's kind of unfortunate we're not able to show you that this year, but you'll have to take my word for it. And we'll have to get you over there sometime. And just a nice sunset view off the bridge going across to the stadium. So let's get into science. And let's talk about our building. It's really one of the major selling points, I think, for science at Baylor, or science at any university. It's what really attracted me and recruited me to Baylor, is the Baylor Science Building. It's opened more than 15 years ago now, but it's still really modern. It's nice. It's got big open laboratory spaces. It's got facilities. It's got teaching areas, etc. And it's home to many departments in science. And so it's a really nice collaborative building where chemistry, biochemistry, biology, physics, environmental science, geology, psychology, and neuro all are in this building, and we can easily interact and collaborate with and just discuss things just by walking down the hall. And so it's a nice collaborative way to do science. It's a big building, but it allows a home to many different science departments. So we have different wings in the Baylor Science Building. So here's the A wing, the C wing, and the E wing. And these wings, or these kind of projections, are really where the research enterprises are, where the laboratory spaces are. And so all the research labs are kind of projecting out in the A, the C, and the E wings. And the classes tend to be more in the classrooms tend to be more in the interior of the building. And just some other views of the Baylor Science Building here. You can see the inside has got an open atrium where you can see down. This is kind of the front of the building over here. Down on the first floor, we have Starbucks and we have 2 other restaurants. And so it's a great place to hang out. Of course, grab a cup of coffee, get lunch if you want to. And we really hope to have this more active area once COVID is long gone. And so we'll get back to normal here. So let's talk about our department, Baylor Chemistry and Biochemistry. It's the largest graduate program in the sciences at Baylor. We have 11% of the total graduate students, and we get about 1/3 of the Baylor Science research space on campus. And so our department is really a big science department and pretty influential on campus and compared to some of the other ones. We have about 20 research active faculty in our department and currently about 90 graduate students. And I will say this is a growth area for us. When I started as graduate program coordinator 4 years ago now, I think we were in the 60s with the number of graduate students. And we've grown it to 90, and we really expect to grow the PhD program to to more than 100 in the next 5 years. And so it's something that we hope you help us succeed and contribute to by coming to Baylor and growing our PhD program. Of course, we need to do this with the growth of faculty hires, and so we've had a number of faculty hiring occur since 2009, including 10 new faculty. Many of them, or several of them, will senior hires. We have 2 in 2019, and we hope one more in 2021 is hopefully going to happen. And so, and then we have more planned for 2022. And so we definitely are growing our research enterprise here. The base stipend for graduate students is $25,000 per year. Plus, we offer recruitment enhancements, and this is to, of course, attract you and convince you to come to Baylor, that we're going to invest in you, and hopefully you're going to be successful during your graduate degree here. You receive, in addition to that, health insurance subsidized 80%. And so the university will pay 80%, and you're responsible for the 20%, just as a way to share health insurance now. We offer free tuition as well, so there's no tuition cost once you're accepted into Baylor. Student fees are kind of a success story I just wanted to highlight for a second. We used to charge significant amount of student fees, actually, and we worked really hard and got them reduced last year, or in 2020, to 50% student fees, which ended up being about $96 a credit hour. Depends on how many hours you take, based on how many fees you pay, but we're able to get them reduced. And what I'm really pleased and excited to announce to all of you is that starting this summer in 2021, student fees are going to be going to $0 and going away. And really they are going to be rolled into this free tuition remission part of this offer to you. And so there will be no more student fees associated with going to Baylor anymore. Student fees are really used to provide access to the Student Life Center, to a lot of exercise and sport-related activities in the Student Life Center. Again, I wish I could show you that. We have the largest indoor rock climbing wall in Texas. We have aquatic center, we have basketball, racquetball, and really an amazing weight room and fitness room and events. And so it gives you access to all of that. It also gives you free tickets to many of the sporting events I've already mentioned. And so take advantage of those as opportunities while you're at Baylor to maintain this healthy lifestyle in addition to research. And now it's free. And so this is really a great thing that we've been working towards. In the Baylor Science Building, we have several facilities. You're going to have a live tour of some of these facilities, but I just wanted to overview them in case you miss out on the live tour event that we have. First one is the Center for Mass Spectrometry, or Mass Spectroscopy. It includes several really top-of-the-line modern mass spectrometers, including a SYNAPT G2, a QTOF, Orbitrap, ICP-MS, all available to use in the facility. The Molecular Bioscience Center includes many equipment and resources to help in biochemical, molecular biology, genetics, cell biology type research, including qPCR or RT-PCR, many imaging instruments, plate readers, autoclaves, tissue culture, cell sorting, things, just really too many instruments to mention here to help with biochemical research. We have the Center for Microscopy and Imaging. This is really houses our top-of-the-line, high-tech instrumentation, confocal microscopy, electron microscopy, scanning electron microscopy, AFM as well. It's not listed here, but we have an AFM, atomic force microscope. And in coming next year, we have a brand new TEM. And so we're getting a brand new cryo TEM that we've already ordered. It's just being built and hopefully will be installed sometime in the coming 12 months or so. I think sometime by the end of 2021, it'll be installed. And so hopefully you'll be able to get to use that. NMR Center, we have several NMRs, mostly aiding small molecule based research, organic and inorganic chemistries. 600, 500, 400, several 300s, etc. We also have an EPR um, instrument here within this facility. All of these main facilities here have facility directors. These are permanent staff, supported people, that PhD level staff support that work in these facilities and help train you on the instrumentation. I think one of the main benefits for you as a student at Baylor is the ability to work in any of these facilities hands-on, right? And so we really try to promote hands-on training, instrumentation, running of your samples, etc., so you can really get the best understanding and exposure to all of our amazing instrumentation here. We have several other facilities, really didn't fit on the slide, including the computational lab, biophysical lab, a lot of fluorimeters, other types of spectroscopy, calorimetry, and we have electronics and machines and glass shops as well. And so it's even more than what I'm showing here. And all of this is really available to you to help and facilitate your research progress. Just highlighting a couple things in the X-ray. We also have X-ray facilities, so this small molecule X-ray instrumentation. Here's the mass spectrometry lab. Here's a 600 sort of walk-up NMR instrument here. And I just want to highlight, we routinely do this advanced instrumentation workshop. We weren't unable to do it in 2020, but I'm hopeful we can do it in 2021. It's this where we really highlight and outreach to many colleges and universities in the area that don't have as much advanced instrumentation. And we really allow undergraduate students to come to Baylor and get hands-on training and expertise at all the instrumentation I just showed you. And so these are many of the students that participated in 2019, and we really rely on the graduate students and the faculty to run workshops that highlight a lot of our instrumentation. And so hopefully you'll be involved in that as well. And maybe some of you actually came in 2019 to our advanced instrumentation workshop. So let's get into our program, chemistry and biochemistry program. What are the requirements? So what is graduate school like, and what do you have to do to progress through our program? So we're going to break this down by years here. Coming in the fall, you'll be year one. In year one, it's a lot of courses, and it's some being a TA and helping with our undergraduate laboratory courses. But hopefully the idea is, as you go through year one and get through your courses, which we'll come to in a couple slides, you're going to be TAing, you're going to be starting some rotations and research projects. But the idea is you're going to get into research pretty quickly. And in fact, doing rotations across different laboratories will help you get in and do research. And then by year two, you should be done with courses and you should be full on doing your research progress. Let me point out a couple benchmarks that we have in our program. One is the pre-candidacy exam. This occurs at the end of year two. The pre-candidacy exam is basically a way for us to make sure that you can write a research proposal based on the proposed thesis research that you would like to do. And so let me elaborate just for a second. The idea here is that you're going to write a research proposal on your thesis project. And so you will be writing and defending a NIH style or NSF style research proposal, and something that will help you plan for years 3, 4, and 5, right? To give you the background literature, to find out what is already known in the area of research you're working on, and then to develop new ideas, hypotheses, and aims to kind of test those over the course of your PhD. And so it really meant to get you off on the right track and to get you focused on research. At the end of year 3, we have our candidacy exam. And so the candidacy exam is really the exam that propels you into PhD candidacy. It's really where we test you and make sure that you are on track research-wise, right? That you've made significant research project progress after 3 years. And our goal for the candidacy exam is to get to the point where you can be an author on a paper, a manuscript, Hopefully something that's published is ideal, but really we're looking for, can you write, can you do research, and can you put it all together in the form of a manuscript? And so we're looking for evidence towards publication at this point. Um, and as sort of your very first paper. And then finally, the defense, which we're not going to talk too much about today. It's a little ways off for most of you, but that would occur probably around year 5 at some point. And you are done, right? When are you done? There's no set time in graduate school when you're done. It's when you've contributed a significant body of knowledge to your field, right? When you've made significant progress and you can say, wow, this is mine. This is the research I did. I'm responsible for this. And you published it and it's out there for the world to see. And that's what we're looking for in a PhD. So graduate school, what is it like? It's really a lot of ups and downs. It can be ups and downs, right? So in the first year or so, you're going to be trying to figure out what your idea is. You're going to be modifying. You're going to be thinking about it some more. You're going to be starting to work on it. And maybe you get to a point where you think you're frustrated and this will never work. But really, you need to probably read deeper, right? And persevere. You need to get a better understanding of the problem, of the research, of different ways to sort of tackle this problem and persevere. And then hopefully it works, right? And you can publish this type of research project that you're working on. You may go through some lows where you think, oh man, someone's already done this, or this research has already really been accomplished. But really, you should look more carefully, right? Is it really been accomplished? Is there something that you've done that's different? Do you add to sort of what's already out there? And then you can submit your paper. And hopefully, after a little bit of revision and et cetera, your paper is accepted, and now you're well on your way towards your PhD and well on your way to your defense. And let me just say that many professors go through these phases all the time, including myself. I go through many ups and downs along with my students. We go through this together. When it works, we celebrate. When it doesn't work, we reassess. We try to figure out how to make it work and persevere. And so professors are in this together with you and guiding you along your research path. So just a little bit more specifically about the program we have here at Baylor. So in year 1, you're going to be taking classes, you're going to be picking a lab, and you're going to be starting your project. And so I'll get to the classes in a second. Let me just say that picking a lab for our program involves rotations. And so you should expect to rotate in at least 3 different laboratories. And this just gives you an idea to experience what it's like to work with a particular PI, with the students in the laboratory, research projects that are going on. And then, test it out, right? There's no commitment at that point. Typically, these are 1-month rotations in 3 different labs. And hopefully by the end of that first semester, or come around December timeframe, you can now be matched into a lab and you can start on your research project. In the second semester. Once you join a lab, really you should be focused on your research project. You should be focused on developing your pre-candidacy exam, which is really your plan for your future thesis project. And that'll culminate really with the pre-candidacy exam at the end of the second year, which we've already talked about. Same with year 3, doing more and more research, right? Fewer metrics on success and progress, just really trying to get results and publish them, right? So the goal at the end of the 3rd year is to get your first published paper as an author, where you can participate in the not only the experiments, the results, the interpretation, but also the writing. And then you reach year 4, where things are rolling. Hopefully, you are on track to get your second paper at this point, and then finally you can write your thesis and defend. So the main metric really of success in PhD is your papers, right? It's what you have accomplished in the research laboratory, and then how and where they're published, right? So getting them published out there for other people to read. The courses, the things you do in year one with the courses and the classes are really a tool to help you or get you started in research. And they're not really the main component of success in graduate school. Success in graduate school comes from research output, research productivity, novelty, and really publications. And so those are what we're looking for once we reach year 5. So really specifically, these are our requirements to get a PhD in our program. And so 5 division courses. So what this means is we need 5 total courses is what you'll be taking. Typically, students take 2 courses in the first semester, 2 in the second, and a 5th one in their second year. Some students can take all 5 of those courses in the first year. Kind of just depends on what's offered and what you want to take. You do need 3 courses in your major area of study. And so I'm going to use an example. Let's say you're organic focused. You're going to need to take 3 organic chemistry courses. But we don't want you to take all organic chemistry courses. We want you to be well-rounded. And so you're also required to take 2 courses outside your major area of study. And so this could be, for someone who's organic leaning, maybe an analytical course in mass spectrometry, maybe a bioinorganic course or an inorganic course, maybe a chemical biology course, something outside of your traditional core focus. And this is just to make you a well-rounded scientist. We also require you to take 2 kind of seminar courses here. One is ethical conduct of research, or ethics. This will be taken in your fall semester or your first term, just introducing you to the ethics of scientific research. And the second semester is a course called scientific communication. This course is really meant to help you think about and start to develop your research proposal. And so at the end of your first year, or second semester first year, you'll be thinking about, what do I want to do in my thesis? You'll be working on it in this course called scientific communication. And then you'll be doing some research over the next year, right? Over and through year 2, where at the end of year 2, you can develop your pre-candidacy exam research proposal. We have one little facet that's kind of in between all of this. This is something called qualifying in 3 areas of chemistry by the end of the second semester. And so let me just describe, or take a second to describe, what this means. And so not only do you need to take 3 courses in your major area and 2 courses outside of your major area, you need to be qualified in 3 of the 5 areas of chemistry. This can be done 2 ways. And so the first way is taking an ACS exam. And we will give the ACS exams in all 5 areas of chemistry. And you have the opportunity to take them more than once if you so choose. And if you pass that with a 60 percentile or greater, you have now qualified in that area of chemistry. So again, I'll use my organic example. You're an organic student. You want to take 3 courses in organic chemistry. Let's say you qualify or you pass the analytical exam. Now you've qualified in analytical chemistry. That leaves you free to take 2 courses of something else. Maybe you're interested in biochemistry or inorganic chemistry. And so you can take and focus on 2 courses there. Let's say you don't want to take these ACS exams, or really maybe you didn't pass any ACS exam. The other option is to just take a course in that area. Take a course and pass that course with a B or a better grade. And so just taking a course in analytical chemistry or any of the areas of divisions of chemistry fulfills that requirement of qualifying in that area. So again, if you're organic chemistry, you take a course in organic chemistry, you take an analytical course, you take a biology course or biochemistry course, you have now qualified in 3 areas of chemistry. And you just have to do that after 2 semesters. And so this is what we're looking for. Again, it goes to being a well-rounded student, and things that you learn in other areas of chemistry really can open up your eyes to interdisciplinary things that you can do with your own research path and your own thesis project. couple other things that we require are at least 2 semesters of being a TA. It can be more than that, but it needs to be at least 2. This will depend a lot on sort of the funding and the laboratory that you join, on when you can be put onto research associate or when you are a teaching assistant. And so, of course, just as a reminder, we will fund you and your stipend for the time frame that it says in your offer letter, typically 5 or 6 years, full stipend. It's just a matter of, are you going to be a teaching assistant or a research associate? And a lot of you may envision yourself being teachers in the future, instructors or professors, and you may want to get many different teaching opportunities in different courses. And some other of you may not want to teach at all, and we recognize that. This helps us support the undergraduate courses and laboratories that we need to do as a department. And we need your help with that. And so this is definitely a requirement. I've already talked about the second year pre-candidacy exam involving this research proposal. And the third year candidacy exam, again, looking towards an evidence for the first research paper. Again, these happen at the end of your second year and the end of your third year. The last requirement is really 2 publications accepted before your defense is scheduled. We do have a requirement that 2 publications are required for a PhD in our program. We think this is just a benefit for you and us and everybody really to show that you have accomplished something significant during your PhD, right? You have these at least 2 publications that has your name on it that you can use to get your next job, whatever that is, industry, academics, government, wherever. And so you have something significant to show for it. And so we are requiring that before you can defend your thesis. And then, of course, writing and defending your dissertation will be at the very end. So this is it, really. I mean, this one slide outlines all of the requirements for our PhD program here. The next few slides, I'm going to just briefly show you the courses that we tend to offer in each of the areas of chemistry. And so you can start thinking about maybe what courses of interest to you that we offer. So here's analytical and biochemistry courses that we tend to offer routinely. These rotate, and so we don't offer these every single semester. We always offer at least 1 course in every area of chemistry, and sometimes we offer 2 courses. And so these courses will rotate semester by semester in sort of this cyclic order and who's available to teach. And so there are several analytical courses, several biochemistry courses. One thing about biochemistry, there's several courses in biochemistry that count in 2 different areas of chemistry. And so this one in particular, 5345, counts in biochemistry, but also analytical chemistry. We have the same thing for 5347. This will count in biochemistry, but also physical chemistry. And one more, 5306 will count in biochemistry or inorganic chemistry. And so these are kind of interdisciplinary courses, some of them, and you can use them how you want. One student may choose to count this as a physical course. One student may choose to count it as a biochemistry course, right? And that's kind of up to you. It provides some flexibility in the types of courses you take. Other courses here in inorganic chemistry, organic, and physical chemistry. I'll just pause for a second while you take a look at these. Of course, you can pause the video as well if you want to. We do offer many times other special topics courses that can be somewhat random, but a lot of times revolve around getting new professors. And so new professors will develop new courses a lot of times, and we can add to the course offering or develop a special topics course in some area of chemistry. So I want to go through and just give you a visual viewpoint of many of our faculty and all the different divisions and areas. And this is just meant to highlight some of the faculty that you can visit with during graduate recruiting weekend. and ask more specific questions about their research programs, right? So in analytical chemistry, we have Dr. Chambliss. Dr. Chambliss is also the Vice Provost of Research on campus. Dr. Saluki, interested in proteomics and exomics, different types of metabolomics, etc. And Dr. Gallagher, interested in glycomics and glycans and mass spectrometry. All of these guys are really experts in mass spectrometry, just coming from different areas, environmental, omics or cellular based, and then glycans or sugars. Biochemistry faculty, we have Dr. Jung-Hun Min and Dr. Brian Shaw. Dr. Min is a structural biologist interested in DNA repair. Dr. Shaw is interested in biophysics and bioanalytical chemistry related to protein aggregation diseases. He also has a really good outreach program for vision students, vision impaired students. Up here is myself, Michael Chexelis. I'm interested in DNA replication and DNA repair mechanisms, genetic mechanisms. Dr. Marilyn Trawick down here is interested in chemotherapeutic agents and cellular biology. She works a lot of times in collaboration with Dr. Pinney and the organic group. The inorganic graduate faculty, we have up top Dr. Farmer, who's the chair of the department, current chair of the department, really interested in metalloenzymes, bioinorganic enzymes, also redox chemistry. Dr. Brian Lindley is one of our newer professors, interested in catalysis and electrochemistry, inorganic synthesis. And Dr. Martin down here is interested in boron-containing ligands and chemistries and bonding properties of those molecules. Physical graduate faculty, we have Dr. Darren Bellert, interested in kinetics, photocatalytic systems using lasers and fast lasers. Dr. Janae Saran is one of our newer faculty members as well, interested in environmental chemistry related to water and ice and chemical and physical properties of those in the atmosphere. Dr. Carlos Manzanares, interested in vibrational states of structures and using lasers again to study those vibrational states and excited states. Dr. Shuford is interested in materials chemistry, but really from the computational perspective and simulation. Our organic graduate faculty, starting first with Dr. Bob Kane, really interested in bioconjugation of cells and antibodies, looking at organic molecules and drugs that can be bioconjugated. Dr. Kevin Pinney, interested in small molecule cancer therapeutics and chemotherapies. Again, the Pinney lab and the Dr. Trawick lab tend to collaborate quite closely together. Dr. Lila Romero is our newest faculty member in organic chemistry, interested in small molecule selective chemical synthesis, also drug discovery as related to that and methodology. And then finally, last two faculty members, John Wood and Dr. Daniel Romo, both of them interested in natural products synthesis. John Wood as well as methodology. Daniel Romo just takes it maybe into cells a little bit more, thinking more about chemical biology and how natural products can be utilized in cells or for therapies. So that's our graduate faculty. And so hopefully with that, you can ask these guys some more specific questions during your faculty Zoom meetings. Let me just switch gears for a second and just ask you to think about what is the most important thing in choosing a lab. So what are you interested in a lab, right? Is it the mentor specifically, the project, other people in the lab, maybe the techniques, something you want to learn, maybe the prestige. And so this was taken from a survey of incoming first-year students from a colleague of mine at UT Southwestern. And most of those students in that year decided that the mentor was the most important thing in choosing a lab. And maybe you guys feel the same way. And if that's true, you definitely want to meet with different mentors and get a feeling for how they run the lab, what the research projects are, how they interact with the students, what they expect, etc. One more thing, I prefer a lab where PI works in the bench, other lab members guide me, the PI micromanages the work. Generally independent people are generally independent, or maybe you just want to be left alone. Again, same first year students from that same group at UT Southwestern. Most students appear like they want other lab members to help them out, learning techniques, probably getting started, thinking about projects. But then they want to be generally independent, right? You generally want to drive your project forward. You want to have your own research project, but you want it to be in a collaborative, fun research environment. My advice to you is find an advisor who is a good scientist for you, right? Someone who you respect, that you can learn a lot from with regards to the science that you're working on in an area that you are really interested in, and someone who can really help you develop your scientific breadth and depth of expertise. But also pick someone who's a good mentor, right? Someone who's going to be a good mentor to you. And there can be different types of good mentors, right? Different people prefer different things, right? So someone who's a good mentor to you may not be a good mentor to somebody else. But find someone who can really be a great mentor to you. And I'm going to say this is really important, not just now and during your PhD, but really for the rest of your life. And as an example, my PhD advisor, I've been out of his lab for about 20 years now, and I still stay in touch with them. I still email him. He emails me. We bounce ideas off each other, and he's really been a really great support for me as I've developed into my own scientist and had my own lab now for about 15 years. And so I still go back to him. I still ask his advice, and that's a lifelong process. So as you think about that, right, and choosing a good mentor, choosing a good scientist, you're going to meet with several faculty members during Zoom meetings during this virtual recruiting weekend. And just to give you a primer, right, something that you could do to ask the professors what to do, or ask questions to them about their research, or about them, or about their students, or how they mentor, or what their expectations are. And I'll just again pause for a second while you take a look at these. You could also pause the video, I'm sure, and get look at these more specifically. But these are questions just as primers that you could use to ask professors. Maybe you have some of your own, but think about it. Try to get as much information as you can during these Zoom meetings. I know it's hard, but you really got to be looking out for yourself and figuring out, what is this guy like? What's this professor like? How will he help me become successful? What's it like to work in his lab? So figure these things out. And during our recruiting weekend, we're also going to hopefully give you opportunities to interact with students. We can do this in a couple ways. We have a live facility tour that the students are going to run. We also have poster sessions that probably are really the best time for you to interact with students. And then we're also going to have a Q&A session that's going to be live, where you can ask as many questions as you want to a panel of our current students and just figure out what it's like to be a student at Baylor. And again, these are just some primer questions that maybe you can ask that you're interested in. Maybe you have some other questions of your own. And I just want to encourage you to feel free to get all of your questions answered during our recruiting weekend. We don't want you to go away with unresolved questions. We want to make sure that that if you don't get them done in the live session, feel free to email us, me, Dr. Shuford, any of the faculty members, or any of the students you meet, poster sessions or at the panel. All of us will really be happy to answer the questions you want. We want you to come to Baylor, and we want to make sure that you are fully informed when you arrive. And let me just end this presentation with a summary of our program. This is just a numbers slide, really just to highlight some of the things we are proud of. A couple things I'm particularly proud of is growing the PhD program. We are up to 91 students as of fall 2020. And I mentioned earlier, we want to grow to over 100. We hope you are part of that growth. And we hope that we can get there in the course of the next 4 or so years. I'm also really proud of the increase in funding, extramural funding that we've had. And we've had about 3 times funding increase over 7 years. In 2019, we've had about 2.7 million funding. I just saw the numbers for 2020 last year. We are over 3 million. So we are continuing to grow our research expenditures and our extramural funding. And so we're super happy about this. Growing research output and having the ability to do cutting edge research requires funding. And so we are having much more success in this lately, and we know this will continue. We have many resources to help you with your research projects here in the BSB and beyond. Many research faculty to choose from and help you be successful on your research program, and something that we're, again, going to be adding to in the future and growing this number, hopefully towards the 25 level of tenured and tenure track research faculty on campus in our department. And then finally, we are always working to bring the average years to earn a PhD down. And I'm going to say when I started, this average was 5.5 years, and we've streamlined a number of things. And of course, I've been a graduate program coordinator director for 4 years now. But it takes a while, right, to bring this average number down if we are graduating students in 5 years. And that's our goal, is to get just under 5 years, right, average years to earn a PhD. And we hope with a new streamlined program and clear requirements that this will be easier for our students to accomplish. Finally, you can always get more information on Twitter all the time, at our website, emailing Dr. Schufert or myself as well. And let me just end by saying thank you for getting through this video presentation. I hope it answers the nitty-gritty of our research program, of our PhD program in chemistry and biochemistry. I'm really excited about the future. I hope you guys become a part of the future, and I hope you guys have a great time during our virtual graduate recruiting weekend. So thank you very much.